Chapter 6 in our geotechnical design course is the deep foundations. We have studied the shallow foundations. We have taken one example for shallow foundations, which is the isolated. We've studied the case with isolated with normal force and normal force with moment, and this moment would be variable in direction or fixed in direction. Now we are going to go to the deep foundation. Deep foundation, the well-known type of deep foundation is piles. You have all at least heard about it. Some of you might have seen it in some sites. What is the deep foundations and piles? This is what we are going to discuss here. Types of foundations, it's either deep foundations. Deep foundations is divided into bored piles and driven piles. These are the two main types. There is a third type that we are going to discuss. Bored pile is the pile where we drill. This is a machine. Just to know what is the size of this machine, look at this small thing. It's an engineer next to the machine. So this is at least, say, 20 meters height. So this machine, it drills in the soil, and when it drills into the soil, for this bored piles, we have really many subtypes. But anyway, the idea is we drill a hole, we put concrete and reinforcement in this hole, we end up with the pile. But the differences will be when to put the reinforcement. Should I put it in some methods? I can put it at the start, and this is very good. And so in some methods, like this one in this photo, I cannot do this because I need to pour the concrete first to keep the hole open, and then insert the reinforcement cage. And usually this is very bad because reinforcement does not reach the bottom of the pile, and it may not reach even half the height of the pile. So in this case, we pour the reinforcement we pour the concrete first, and then we start trying to insert the reinforcement in place and as much as we can. So this type of bored piles is very easy, very quick, very cheap or very economic, but it cannot be used for piles that are subjected to moment. It cannot be used for piles that are subjected to tension, because if we do this, we will not be able to move our cage to reach the bottom of the pile. The other type is called driven piles. Driven piles is same as this one, but the piles are casted outside, or we cast the pile outside the site or outside the location where it should be inserted, and I get it precast and just hammer it in place to reach the maximum depth I can push. Of course, I should have an edge like this to help me in pushing the pile down to the ground, and I should have something on top to hammer on top of the piles. The third type of the deep foundations is called the caissons. The caissons are very huge, big structures that reaches down to deep down into the ground to carry the load from the same idea of the piles. The pile carries the load from the ground surface to good layers. The caissons do the same, but the caissons are much bigger and stronger, and they may be circular, they may be square or rectangular, similar to this one. These are very good to be used inside the water. if I need to reach the bottom of the water, how to do this? Then I have to use a structure like this and put my loads on top of this structure. Why do we use deep foundation? This is you might have heard it many times before, but this is very important, so it has to be repeated every time. Why do we use deep foundations? As a first statement, I should not use deep foundation. This is the first statement that you should put in mind. When I tell you design foundations, you should think of shallow foundation. Don't think of deep foundation. We think of deep foundations when we are faced with problems with the shallow foundation. I cannot use the shallow foundation, then I will go to the deep. Don't start with deep foundations unless you are sure that they are not adequate. So usually for soil, I have a top layer. Usually the top layer in any place is the softer layer or the weaker layer. Then it will be followed by stronger layer. Then it will be followed by the strongest layer. This is usually in 90% of my locations or sites, you will find this. A top soft soil or weak soil, followed by stiffer, followed by the strongest layer. Usually the strongest layer is rock. So for this medium or weak soil, how can I manage? I will manage with shallow foundations. If I have a small building, then my foundations will be very small, settlements will not be that critical, so I can manage with isolated shallow foundations. If I have big buildings, say 4, 5, 7, 8, 10 floors, then I will discover that using shallow foundations is not adequate. You will find this when you discuss your coursework number 2, that it is not adequate. So what should I do? I should use piles. In this case, I will take my piles to penetrate the soft soil on top and go to the strong layer below. If I leave this case and go to the other case, I have very high-rise building, very, very big loads. I cannot just put normal piles. I will need, my piles should be very, very big. I may use very big piles, usually we call it shafts. And so that this can reach very deep layers to reach the rock, so that I ensure that with this building, this very high-rise building, I don't have more settlements than the allowable. So this is my way of thinking. So why we use deep foundation? Deep foundations are only implemented as a result of not having a suitable construction soil layer near the surface of earth. If I have good layer, don't think of deep foundation. Therefore, we resort to penetrating the soil at great depths to obtain a suitable surface for construction to solve one of the following problems. So these should be the problems that are facing me. First problem is bearing capacity. If I use the bearing capacity equation and I find that the soil is the bearing capacity is not adequate, or I use the settlement equation, I check the settlement of the footing and I find, say, a 20 centimeter settlement. It's not possible. These are related to soil, these are related to loads, tension and horizontal load. If I have tension, shallow foundation is not possible, because shallow foundation can carry vertical load. But if you have tension, then the tension will carry your foundation above the ground. So it should be, you should use piles or deep foundation, or you have horizontal load. With small horizontal load, the friction that we have studied before, the friction between the footing and the soil will be adequate. But if the load is high, then this horizontal load will need piles to be used. So it is tension or horizontal load. If you have tension or horizontal load, then you should go to piles or deep foundation. Here we say that since piles are the most important type of deep foundation, so this is what we are going to study in this lecture. This lecture will be a very long lecture, so we'll have to split it into many parts. Pile is a structural element that transfers the load through weak soil until it reaches strong soil. This is a definition. The dimension of the pile are calculated according to the depth of the weak soil. Of course, if I have, say, 50 meters of weak soil, then don't expect that your piles will be 10 meters, 20 meters. You will have to penetrate the 50 to reach below. But if I have a layer of 10 meters, then my piles would be, say, 15, 20, something like this. Types of piles. Just to avoid being confused, I might have said this thing before, but if I say that I have a group of students, I want to divide them into groups. There are many groups. I can divide them male and female. I may divide them tall and short. I may divide them engineering students and medicine students. I may have lots of types. So don't be confused to open a reference and find that somebody is dividing piles into groups that you did not study. They may be divided according to the material. Concrete, steel, timber, steel with sections, steel sections, precast, composite, concrete and steel. This is one type. You may find this. So it does not mean that this is the only types of, but this is just a way for dividing the pile groups. I may divide them according to the method of installation. How I'm going to construct the pile. I'm going to do it a board pile, similar to what we have just said in the introduction, or driven pile, and as we said, board pile, in this case, I will have to go into the subgroups. It's not just board. Board itself, there may be many types of board piles. So this is what we are going to discuss here. They are piles that are implemented. What are board piles? They are implemented by digging in the soil to the size of the pile body and supporting the size of the drill. If I drill a hole and I leave it for 5 minutes, it will be closed. I will not have the time to drill and then go away, bring my reinforcement, put it, and then bring my concrete and put it. I don't have the time. During drilling, I have to put something to keep the hole opened. How will do this? By putting a casing. What is the casing? It's a tube, steel tube. And I drill through this steel tube. Every time I drill, the steel tube goes down till it reaches the depth. Of course, this is very expensive. To have a steel pipe for every pile, imagine that you have a building with 200 piles. Of course, you may use the steel tube for many times. You use it in the first one and then take it out, put it in the second one, and so on. But even though this will still be expensive. So I can use this type of board piles, but it will be expensive. So there are other means for keeping the hole closed. I can put inside it water, but water is not very good. Maybe I will put water and still it will collapse. So sometimes or usually they add to the water something called bentonite suspension. If you might have heard this in the drilling of boreholes. In drilling of boreholes, to keep the hole opened, they put water with bentonite. Bentonite is something like a clay material that is a suspension. It is suspended in the water. It keeps the water all the time moving, so it prevents the sides from collapsing and closing the hole, or at least delay this. So bentonite is okay. Sometimes the bentonite also, we call it in Arabic بتليس الحفرة. It covers the sides of the hole. So instead of having the side of the hole to be sand, it will be covered with a silty material that will help the hole to be opened longer time. So this is the bentonite suspension. There are other polymers that may be added to this material, and it would help. So this is the first type that we have just discussed. I will drill the hole through a pipe, a steel pipe, and then I reach the bottom, and once I reach the bottom, the required depth, I will take my machine and the hole will be opened because of the existence of this pipe. Then I will take the cage, the steel cage, put it, in this case it will reach the required bottom exactly. This is, by the way, this is the best types of pile, but it is the most expensive type of pile. I will put the concrete, I will put the reinforcement, then I will start pouring the concrete. Of course, here there is something that I should always say. Pouring the concrete in a pile is like pouring the concrete in a column. Usually, if I put the concrete from the top of the column and I leave it to fall down, there will be some kind of segregation. The material of the concrete will be subdivided into the big material will be at the bottom, the small material will be on the top. I don't want this, so that's why we use something called trimmy pipe. Trimmy pipe is a funnel ended with a big tube, a long tube. The long tube reaches the bottom, so I'm always pouring the concrete through a tube till it reaches the bottom. When it reaches the bottom, it starts coming out of this tube, and I start pulling the tube above till I reach the ground level. So in this case, I'm sure, very well sure, that my cage has reached the bottom. This is one thing. I'm also very sure that concrete with a very good quality started from the bottom till the top. It was not contaminated by the soil because there is no interference between them. Because when I put the concrete, I start pulling my tube above. So what is inside? It is pure concrete, no soil. So this is as I said, the best type of piles. The third, the other type is, we'll discuss it later, but there is something here. This is how this is what I've just said, but there is something here. You may take it into consideration. Do you know something called a boiling phenomena or quicksand phenomena? Usually, when I have we have studied effective stress and total stress. If the water pressure is high, then the water will be carrying all the loads. So imagine that below the pile you have water pressure that is very high. So what will happen? Your pile will start sinking and it's failure. So when we are drilling a pile underwater, we have to ensure that inside the tube where we are drilling, the height of water is equal to the height of water outside. Because if the height of water inside is low, imagine that you are, of course you are drilling, so you are taking the drilling material outside. So you are taking the drilling material with water. So the level of water inside started to decrease, and the level of water outside is high. So what will happen? Water will come from the higher pressure to the lower pressure. This is called the boiling of soil, or a quicksand phenomena, or something like this, the same as phenomena as the quicksand. Of course the quicksand is for a different reason, but it means that water here is the carrying media, not the soil, and in this case it's a failure for the pile. So that's usually they tell you, take care during drilling not to reach the boiling of the soil, otherwise you are disturbing the soil and you are taking the soil to failure before putting the pile, and this is very, very bad. This is the shape of the trimmy pipe. This is the funnel. This is how they pour the concrete, and this is how they put the piles. This is the tube, the steel tube where they drill from inside. Another type, we said that we have a type that we are going to use a tube, steel tube or steel casing, and we said that this is the best one, but we said it is expensive, and not all projects we need very high quality piles. In some cases we just need normal piles. How to do these normal piles? They use this screw drilling machine. Once you start drilling, the hole will not collapse because you have a screw all of the time rotating. Anything that will fall inside, it will be taken outside. So the screw can reach very quickly the bottom. To say it can reach very quickly the bottom, it means that the type of soil can ensure this. You cannot do this in soil with maybe boulders, because but if you have sand, silt, clay, this will be very, very good. By the way, this type is used in Alexandria. The type of soil in Alexandria is very suitable for this, so it is very well known there. So you start drilling till you reach the bottom. If I take this screw outside, what will happen? The hole will collapse. So I need to put my concrete before removing this screw. How can I do this? By the way, screw, it's called auger. The technical term is augering. We are using this, an auger, to drill. So what they do, they put a tube inside this screw or this auger. So there is a pipe inside here, similar to the pipe of the trimmy pipe that we were using before. So you just bring your pump, pour the concrete inside the screw, and every time you move up, you push more, you move up, you push more, till you finish reaching the ground level with a hole that is full of concrete, and very good concrete because it was not contaminated by soil. But what is the difference? So far I don't have any reinforcement, I just have concrete. In this case I will have to bring my cage, try to insert it inside. Very, very difficult. And if you are a professional contractor and you know you are following exactly everything and you have the best equipment and you are super, you will manage to push this, but at least 2 meters at the bottom, they are impossible for you. This if you are a super, a hero. But if you are not, then in this case don't expect more than 50% of the length of the pile, or maybe it would just reach 4 to 5 meters and it will be stuck because there are many reasons. You are not pushing steel cage in water. You are pushing steel cage in concrete, very dense concrete, and piles should be dense concrete. So you are trying to push it in a dense material. There is something here very good is the friction between the soil and the pile. Because of course I don't expect here the surface to be smooth. How will come? It will be smooth. It's just the surface resulting from the drilling of this auger and pouring the concrete. So the concrete is just going down to fill the space. But I'm not expecting that the surface will be smooth. I don't want it to be smooth, but because I need friction. The more rough the more the surface is rough, the better the friction between the pile and the soil, and the more is the load. So it is good for me to have something like this. I expect here the surface not to be rough. But in the previous case, when I had a steel tube, of course I expect that the surface will be smooth. And in the same time, this tube will have a thickness. So maybe the concrete did not fill the whole space. I will expect later that the soil will move to grasp, to fill the space of this tube, steel tube. But for this type, what is very, very good is the friction. The friction between the soil and the pile will be very good, even better than the other type of the one with the casing. But as we said here, the problem is trying to push this reinforcement into a very dense concrete, and you need to push it vertically, exactly vertically. If it is just shifted 1 or 2 degrees, the reinforcement will touch the sides of the hole, and you will not be able to move it later. So usually we push this cage till I reach maybe 4 or 5 meters, and I find that I cannot move any more. So I will have to just cut the steel reinforcement at this level, and I will say this is the end of it. So usually don't expect in normal sites or in low grade sites that you will have reinforcement reaching more than 4 to 5 meters. In very good sites, you may reach the bottom of shallow piles, but at least the last 2 meters are impossible for the cage to penetrate. The other type is the driven. You have seen the driven in the introduction. This is how we hammer it. This may be another type where the driven, they introduce, plus the hammering, they introduce vibration also. It helps in some cases to help the pile to go lower and lower, easier in the soil. This is the driven. This is an illustration. This is the driven pile. Of course, it will not be blunt like this. It will be tapered to have an edge here. Then I will going to push till I reach the required level. Pile resistance. To design a pile, I should check many things. What are these many things? First, I should discuss, are these piles working alone? If I have one pile, my footing will have only one pile below it, or many piles below it? It will have many, usually it would have many piles below it. So if I design a pile, I will design one pile. Then I should check what will this one pile do if it works in a group. We are going to discuss this very quickly now. there are three things that I should check for single pile, and the same three things I will check for the group piles. For the single pile, I will check the bearing capacity under vertical compression load, the capacity under vertical tension load, and the lateral capacity of the pile. So the pile should carry vertical load in compression, it should carry vertical load in tension, it should carry horizontal load in any direction. This as one pile. And I should repeat the same in case of all of the piles together. From where does the pile take its strength or gain its strength? The pile gain its strength from two things. I will just show you an illustration. If I have this bag, this bag, consider that this bag is heavy. I have two ways for carrying the bag. Either I would put my hand below it and I would be carrying it. So this is I can describe it as end bearing, because the end of my bag is bearing on my hand. So this is end bearing bag. If I just put my hands around the bag, I'm not carrying it from below, I'm just putting my hand around the bag. The bag is not falling, it is in the same place. How it is there in this place? Because there is friction between my body and the bag. Then you have two types of way for carrying the pile. The soil can carry the pile in the same manner. It is either end bearing, which means that the pile is just resting on the bottom of the soil, or the pile is friction, which means that the soil is trying to catch the pile and prevent it from falling down. So these are the two types. It's either I have base resistance or skin friction. This illustration is very good to remember. If this is the pile, imagine that this pile is a tree trunk, big tree trunk. To carry this tree trunk, either the same that what I have done with this bag, either I can carry the trunk from below, I can put my hand below the trunk and carry it, or I can put both my hands from each side, and maybe it's not me alone, me and you and everyone here, we all contribute together and put our hands along the shaft of this tree, and we can carry it up. So this is the friction. But is it either a point bearing or a friction? No. Usually it is the combination of both. It's as if you are carrying this bag, one hand around and one hand below. So you are carrying both. Next lecture, we are going to study how to check a single pile. But before I go into this, I will just show you illustration of the difference between a single pile and a group pile. Okay, we said that these are the cases of friction and end bearing, but I will have to do some kind of simulation to understand the difference between the friction and end bearing in case of single pile and in case of group piles. Imagine yourself that you are in a swimming pool. If you are in a swimming pool, then what happens is that in this swimming pool, you can swim with two ways. Either you use your feet, this is similar to the end bearing, or use your hand, this is similar to friction. So this you can do it yourself. If you are in a swimming pool, you will use both your feet and your hands to swim. Imagine after a while that this swimming pool started to be like this, very crowded, you will still be like this person. You will still be able to use your feet because it's below you. But your hand, where should I put my hand? If I put my hand, it will touch whoever who is next to me. Then in this case, my efficiency for swimming has decreased due to the interference between my friction, which is my hands, and the hands of the others. This is exactly what happens in piles. The end bearing will still be the same. If you, instead of having this one pile, you have next to it 3 or 4 piles. The end bearing will be working very good. But the friction, how come I say that the soil next to my pile is carrying the pile and I have another pile next to it and the same soil is carrying it? It means that the soil, instead of carrying one pile, it started to be carrying all the piles around it. So the efficiency of these piles has decreased. So this is the difference between the single pile. So this is the difference between the friction and the end bearing. And what we have just said for the case of the swimming pool is the difference between the single behavior and the group behavior of pile. We can stop at this point and continue next time. Thank you very much.